Okay, we are going to continue working on adding rational expressions. We're going to be focusing today when the denominators are different. So looking at rational expressions who have different denominators. And we're going to go through the process of finding our least common denominator using prime factorization, creating two new fractions, and then rewriting the new fractions with the common denominator so we can do our addition. So we're going to start with our least common denominator. And the way we're doing that is we're going to look at the prime factorization of each. So 8x has a prime factorization of 2 to the third power, so 2 times 2 times 2 times x. 6x squared has a prime factorization of 2 times 3 times x. So our least common denominator needs to take each factor to the highest power. So for example, they both have a 2, but we need to use the 2 to the third power. We also have a factor of 3, and even though the 8x doesn't have a factor of 3, it needs to be included in our least common denominator. And they each have an x, but we notice that this is an x squared. So then we would multiply this out. This would be 8 times 3 times x squared, so 24x squared. So now what I'm going to do is I'm going to rewrite my two fractions so that they have this common denominator. So I have my 1 over 8x, and I need to turn that into a common denominator of 24x squared. So I need to think of what am I multiplying by. I'm going to be multiplying 8 times 3, and I'm going to be multiplying x times x to get x squared. So whatever I multiply my denominator by, I'm doing the same thing to my numerator. So 1 times 3x gives me 3x. I'm going to do the same process for my x minus 2 over 6x squared. Now this is going to be tricky. I'm going to put it in parentheses because I'm going to need to do some distributive property here. And I need to think how I get to 24x squared. And I'm going to be multiplying by 4. So I need to multiply both the x by 4 and the 2 by 4. So I end up getting 4x minus 8. Now that I have my two new fractions, I'm ready to go ahead and add these fractions together. I'm just going to move this out of my way so I have a little bit of space. So now I'm adding my 3x over 24x squared plus my 4x minus 8 over 24x squared. And remember, when we add fractions, we keep the denominator the same. So now I just need to add 3x plus 4x is 7x. I don't have anything to add to the negative 8, so I keep the negative 8. Then the last thing I need to do is just make sure that neither of these can be factored. So I'm looking for like a greatest common factor to pull out of my numerator, which I do not. Okay, here's another one. Now, when I see a polynomial in the denominator, the first thing I really want to think about is, can I factor that? Because if I can factor that, it's going to make it a little bit easier for me to identify what factors I have in common and what factors I don't. So the very first thing I'm focusing on is this polynomial down here, and I'm factoring that polynomial. So I know that I'm thinking of what multiplies to 12 but adds to 8, and I should be thinking 6 and 2. And to get a negative 8, they would both be negative. So I'm going to rewrite my denominator as x minus 6 times x minus 2. My numerator stays the same. So then we're going to continue going here. And hopefully you're noticing, oh, they have one factor in common, but they don't have the x minus 2. So that tells me I only need to change my second fraction, and I need to multiply both the numerator and the denominator by x minus 2 to create now my fractions that have common factors. So I have x plus 3 over x minus 6 times x minus 2 minus 2 times x minus 2 over x plus 6 times x minus 2. Now, in order to add these, I'm going to need to distribute here. So this is going to become x plus 3 minus 2x plus 4. I'm distributing the negative along with the 2 over x plus 6 times x minus 2. Now I need to combine my like terms. So I have an x minus 2x, which would give me negative x. And then a 3 plus 4 would give me 7. So I have negative x over 7. Negative x plus 7 over x plus 6 times x minus 2. And so that's how we're finding common denominators, adding our numerator, simplifying, and canceling out any common factors that we see.